This is Mr. Martin, and these are the video notes for section 8.3, some examples. So we're going to just look at a couple examples. The previous video had the notes for this section. So we're given that AB is perpendicular to BC. So we have, whoop, let's try that again. So we've got a right angle here, and we've got that BD is perpendicular to AC, so I know that these are both right angles over here. And I want to prove that triangle ABC is similar to triangle BCD. Okay, so we've got these two overlapping triangles that I want to prove are similar. So the first method that I usually look to when I'm trying to prove two triangles are similar is angles. All I need to do is get two pair of angles congruent. So I've got AB is perpendicular to BC, and I've got BD perpendicular to AC. So that's given and given. So since AB is perpendicular to BC, I know that angle ABC is a right angle if segments are perpendicular, they form right angles. And since BD and AC are perpendicular, really I want this right angle over there. I'm going to call it angle 1. So step number 4, angle 1 is a right angle, same as 3. And then since they're both right angles, I know they're congruent. Angle ABC is congruent to angle 1. Right angles are congruent. So that's one pair of angles congruent, and then I need another pair. So you see these two triangles overlap, and actually angle C here is common to both. So that's going to be a reflexive angle. So step 6, angle C is congruent to angle C by the reflexive property. So I have a pair of angles here, I have a pair of angles here. That's all I need to get my triangle similar. So step 7, I've got triangle ABC similar to triangle BCD by angle, angle, similarity, and I had the steps from 5 and 6. Alright, so moving on to example 2. So this one's a little different. I have the ratio of MO to MP is equal to the ratio of MS to MR. So I've got MO to MP is equal to MS to MR. So what this tells me is that the ratio of two pair of corresponding sides are equal. Okay? And I'm trying to get this little triangle similar to this big triangle. I also notice here that this angle in between those sides is a reflexive angle. So basically I've got enough right there to prove that the triangles are similar. So let's get this into a proof. Step 1, I've got MO over MP is equal to MS to MR. That's given. And I've got that angle M is congruent to angle M. That's the reflexive property. Okay, so this is really two pair of sides, and again we're talking about the ratios of the sides, and this is my pair of angles. So I've got enough to say that triangle MOS is similar to triangle MPR by side, angle, side, similarity. Don't forget your little similarity symbol. And even though this seems like it would indicate that we would need 3 steps, we really only need 2 because step 1 has both of the ratios. So this S stands for the first ratio, and this S stands for the second ratio. And that's it. Example 3. So we've got that HM is parallel to JK, and we know that parallel lines give us angles that are usually congruent. So I'm looking at the little triangle at the top and then the whole big triangle. Since these lines are parallel, I know that these angles are going to be congruent. Those are corresponding angles. I also know that these angles are going to be congruent. I also know that angle G is reflexive. So you have some choices here of what you want to use. I'm just going to use 1 and 2 and 3 and 4. So I've got that line HM is parallel to line JK. That's given. And from that, I know that angle 1 is congruent to angle 2. Parallel lines implies these are corresponding angles. And then I've got angle 3 is congruent to angle 4, same as 2. And so this is a pair of angles, this is a pair of angles. That's all I need to get the triangle similar. So I've got triangle GHM similar to triangle GJK. Angle, angle, similarity. Again, don't forget your similarity symbol and the steps that you have your parts in. And that's it. So again, as always, if you have any questions, make sure you write those down so you don't forget to ask. We'll see you next time.